All right, in this video we're trying to decide if these figures are similar. So for two figures to be similar, two things have to be true about them. One, corresponding angles are congruent. So when you match them up, all the corresponding angles are congruent. And corresponding side lengths are in proportion, which means that if I make the ratio of one side to its corresponding side will be the same as the ratio of another side to its corresponding side. So let's take a look at this first one. First of all, angles, check. They're all right angles. So every angle is congruent to every other angle, so all the corresponding angles have to be congruent. Next, we've got corresponding sides. Well, this looks like the short side here, and this is the short side here. This is a rectangle. So 4 corresponds to 8, and this 5 corresponds to 10. And is that true? Is 4/8 the same as 5/10? Well, they're both 1/2, so check. Sides. So these two are similar. All right, let's take a look at another one. Here, well, we got, again, all the angles are right angles, so check. And then next to it, let's see, we've got the longer of the two sides of the rectangle, 20 to 10, should equal 15 to 8. But if we look here, 20 to 10, well, that's 2, but 15 divided by 8, not 2, right? That's actually, what, 16 over 8 would be 2. So if the sides are not in proportion, sides, no, not similar. Okay, let's take a look at some more. Let's see here. Here we have, again, angles. Are good because they're all right angles. And here we've got 35 to 24 will be equal to 20 to 16. Let's see, 20 over 16, those are both divisible by 4. So let's see, that is 5 over 4. 5 over 4. It's 35. Let's see. These are both, I can reduce by, let's see, nothing. They don't reduce. So we can double check. I think these are not going to be similar. Well, let's take a look here. Another way you can check is if I said, let's see, 35 divided by 24 is 1.4583333. All right. And 5 divided by 4 is 1.25. So sides, not true. Not similar. All right, let's take a look next door. Here we have, well, this angle matches this angle matches this angle, this one, this one, this one, this one. These are two isosceles trapezoids. So check on angles. For sides, let's see. We've got 20 to 23 and 40 to 48. So 20 to 23, 40 to 48. And let's see, if I divide 40 and 4, see, that's both divisible by 8. So this is equal to 5 over 6. But this doesn't reduce to 5 over 6. If I divide this by 4, I'd have to be able to divide that by 4. Not quite right, so not true. Sides, not in proportion. Not similar. All right. Down here, angles, of course. Again, we've got a pair of rectangles, so angles check. And let's take a look at our side lengths. Let's see. The long side is the 42. The long side down here is the 35. So 42 to 35 needs to equal 36 to 30. So let's see. 36 over 30, that's the same as 6 over 5. We divide them both by 6. Divide 42 and 35. Let's see. They can both be reduced by a factor of 7. And then 42 divided by 7 is 6. 35 divided by 7 is 5. They both reduce to the same number, so these are true. Sides, check mark. Similar. Next up, let's see, we've got again angles, check mark. They're all right angles, so it works. The long side here is a 35. That must correspond to the 21. So 35 over 21 needs to be equal to the short side is 30. The short side over here is 12. 30 over 12. So I can divide both of these by, first of all, these things even look similar. I mean, you can't always trust the diagram, but this one was a lot skinnier than that one. All right, anyways. 30 divided by, so I can divide both of these by 6. That's 5 over 2. And here I can divide both of these by 7. That's 5 over 3. Not similar. Not similar, because those two ratios are not the same. All right, let's take a look at the next one. Okay, here we have, let's see, again, all right angles. A lot of these. Check mark on the angles. Okay. Let's see, the long side is 5, the long side is 30, so 5 to 30 needs to be equal to short side, oh wait a minute, no, it's 5 to 36. 4 to 30. Okay. 4 to 30, let's say I can divide both those by 2, that's 2 to 15. Over here, 5 and 36, nothing goes into both 5 and 36 other than 1, so this can't be reduced, and it certainly can't be reduced to 2 over 15, so not the same sides. So it works for angles, but not for sides. The last one, we're dealing with some parallelograms here, and notice that's 75 degrees, so that's 75. Because these are parallelograms, notice all the sides are parallel, then this is going to be 105 because these two angles need to be supplementary, and this is going to be 105 because these two angles need to be the same. And then down here we're dealing with the same thing, so 75, 105, 105, all right? So here, angles, check mark, we're good. Let's look at the side length. So the long side is 15, the long side is 5, so 15 over 5. The short side is 4, the short side is 12, so it needs to be 12 over 4. 12 over 4 reduces to 3, and 15 over 5 reduces to 3, so check mark. Sides are also in proportion. And one thing I want to make a note about here is that for these really to be in proportion, I should actually check all the corresponding side lengths, not just some. But if you'll notice in a lot of these shapes, since they're rectangles or parallelograms, I would get the same result. So if I did 12 over 5 versus 15 over, it would always turn out the same. So you don't have to check every single one of them if you know the other calculations are going to turn out the same. And all you need to show on these is that check the angles and check the sides. You just show that you've at least addressed both. The angles are probably going to be good on all of these. There we go.